Welcome everyone. Today I'll be solving question number 61 of the 2022 GATE Biotechnology paper. The question is, consider a piston cylinder assembly shown in the figure below. The walls of the cylinder are insulated. The cylinder contains 1 mole of an ideal gas at 300 Kelvin and the piston is held initially at the position Z1 using a stopper. After the stopper is removed, the piston suddenly rises against atmospheric pressure, which is given to you as 1.013 into 10 to the power 5 Pascal, to the new position Z2, where it is held by another stopper. The heat capacity, or CV, of the gas is 12.5 joule per mole per Kelvin. The cross-sectional area of the cylinder is 10 to the power minus 3 meters square, assuming the piston is weightless and frictionless. If Z2 minus Z1 equals to 1 meter, you have to find out the final temperature of the gas rounded off to the nearest integer in Kelvin. So this is the figure given to you in the question. Z1 is where the piston is initially stopped and Z2 is where it moves after the stopper is removed. So according to the first law of thermodynamics, delta V, that is the internal energy, is equal to Q minus W, where Q is the heat transfer and W is the work done. Since it is explicitly mentioned in the question that the cylinder is insulated, that means no heat is transferred. Therefore, Q will be equal to 0. So delta V is equal to minus W. Another formula for delta V is equal to CV into delta T, where CV is the heat capacity and delta T is the change in temperature. Similarly, a formula for W, or the work done, is equal to P into delta V, where P is the pressure and delta V in this case is the change in volume. So delta V, or the internal energy, is equal to 12.5, which is the CV, into the change in temperature, which is T final, which is what you have to find, minus T initial. The T final is unknown. T initial in this case is 300 Kelvin. The volume, or the change in volume, is equal to area into height. Since the change between Z2 and Z1 is 1, that means 10 to the power minus 3 into 1, which is equal to 10 to the power minus 3. So W becomes P, which is given as 0.013 into 10 to the power into 10 to the power 5 into the volume, or the change in volume, which is 10 to the power minus 3. So if you rearrange the equation to find out T final, you can write it down as minus 1.013 into 10 to the power 5 into 10 to the power minus 3 upon 10.5, which will give you a value of minus 8.104 Kelvin. Now that you have this value, you can find out the value of T final. So T final will be equal to minus 8.104 plus 300 Kelvin, which gives you an answer of 291.896 Kelvin. Since the question asks you to round off to the nearest integer, the answer will be 292 Kelvin. That's it for this question. I hope that was easy for you to understand. Thank you so much for listening.